is class 3, and we are starting with. Okay, this means IPython notebook. Okay, so this interface is called as a notebook, and IPython is, this is one kind of package that we use. So this is like on which this Jupyter is built. Okay, so this is IPython notebook. Okay, this is fine. Then now we can go to, let's take see what data we have. Let's take some sample data. Let's say this California data. Fine. Let's import this data as df pd.read csv. Okay. So now df.head. Fine. Now, whenever we want to take, let's say, only a single column, let's say longitude, if we want to take, so we just provide a single column. Okay, we'll get the longitude column. Now, if we want to take, let's say, more than one columns, okay, then what we do, I had shown you this also when we were doing that filtering operation, that we can use those inside a list. Let's say longitude and latitude. Fine. So this would give you now two columns in form of a data frame. Now this is again one pandas data frame. Okay. Yeah, yeah. For just these two columns, you want the data from 10th row to 20th row. Okay. So now I'll show you two ways for slicing pandas data frame. So two ways we will show. One is, let's say this is df, and there is this function iloc. Okay, this is indexing with location. Okay, iloc you can say like that, and there is one function known as lock. Okay, so you can also do like this, and you see this lock is label based. So basically what you will do is you will provide a pair of rows and columns. Okay, so let's say, let me show you. Let's remove this help. Okay, let's first start with lock. So this is the first way, and here first we need to provide, let's say I provide longitude. Okay, just a second. Yeah, and like I showed you one way to do that, this selecting two columns. I showed you one way. Now this is another way how you can again select two columns. Okay, let's say one is to using just, acha, here you use these brackets. You can use these brackets. Let's see. Here longitude. Okay, let's try with these brackets. Df.log. It should be longitude. Just a second. Let's see what's the name if I'm doing it correctly. Okay, let's see df.log, and we need to get the column. Okay, so this is index. So the first is row, and for second is the column. Fine. So let's take column first, longitude. Let's take all the rows. Let's check this ones. Okay, fine. Now you were saying from 10 to 20th row for these two columns, है ना? Longitude and latitude. First, let me show you how it's done, then I'll explain. You see, 10 to 20th row for longitude and latitude. So, using df.log and the square brackets, first you provide the row indexes, okay, and then you provide the column indexes. like we used to do in numpy slicing. Similarly, these are row slicing, these are column slicing. So let's say you want to take multiple columns. Let's say columns, you see they are starting from longitude, है ना? So let's say you start with longitude and you want to go till, let's say, total rooms. Okay, one, two, three, four. Like this also I can do. See, and rows I just need, let's say, 10 to 20, because row indexes are what, by default these are numerical, and I can also assign any index. So you see this, if I just do like this, so you see longitude, latitude, housing mean, total rooms. So starting from latitude going till total rooms, and these are the row indexes. So the column indexes and the row indexes. Fine, makes sense. Now let's say if I want to get everything from total rooms till the end. So like we used to do in NumPy, similarly we can do here also like this. Total rooms till the end. You see, total rooms till the end. Fine, makes sense. And let's say you want to get the last 20 rows. So you can do like this also. Let's say last 20 rows till the end. We'll get the last minus 20 till the end. So this is not giving me minus 20. Let's say let's start with minus 20 and uh, let's go till minus 10. Okay, this is, let's go from, let's just choose, let's see if minus indexings are working also here. Hmm. This would not work here, because here we need to provide the indexes, exact indexes. Okay, and minus में there are no indexes, so here it won't work. So you can just choose between, let's say, 10 to 15. So because these are the indexes. If you want to also see, you can also do, df.index. If you see, these are all the row indexes. You see, they start from 0, they end at 17,000, and the step is 1. Okay, and this is the column index, df.columns. You see these. So this is the column index, this is the row index. Fine. Okay, now there is one more way, using df.ilog. Okay, ilog is a bit different. In ilog, instead of providing names, like here you are putting total rooms, you cannot provide names, but you have to provide the indexes in terms of numerical values, whether 0, 1, 2. So I'll show you, like here we get 0 to 10, and columns we get 0 to 2. So you see, zeroth column and first column, last column would be missed. So using ilock, you can do slicing and all those things by the index numbers, okay, using the numerical part. With lock, you can, if this index was not having, this type of thing, numerical type of thing, then you could have also provided alphabetical kind of thing. Okay. Like I can also show you if there is any alphabetical. No, there are, everything is numerical. We'll see those scenarios also where you can, change these indexes accordingly and try. But in Pandas, basically there are two ways to do indexing. One is lock and one is ilock. When using lock, you can provide the name also of the index, but using ilock you need to provide the index numerical values. Fine. So these are two ways to do slicing in pandas. Fine. Which values in between these values? Okay, let's first reach to this value. Let's say you go to df.ilog. Let's say uh, 3. So third row and zeroth column. Okay, this is the value. So this you want to change. You want what you want to put 20. Now if you see this, see, so this got. changed. So using exact index, using iloc also you can do this, using lock also you can do this. Fine. You can also do like this. See, I'll show you one thing. You can even change a range of values. Let's say, let's try with, starting from 0 till 10 and 0th row. I want every value to be 100. Now you see every value becomes 100. So instead of just providing, so this is what? This is one index. This is the row. Yeah, that's right. Very nice. So now you will get the, this kind of array you can say, and we have whatever value you want that would be broadcasted. So this is known as a concept in Python, broadcasting. One value gets broadcasted to many places. So this concept is known as broadcasting. If in other languages, in Java, C, C++, what you do, you would have to do a loop, and through all this from 0 to 10 you do a loop, and for every value you provide this single value, है ना? That is one way. But in Pandas you can use this concept of broadcasting. Fine. Okay, very nice. Now let's see how to iterate over a pandas data frame. So let's say if you want to do a for loop over a pandas data frame, you want to go into, let's say, for item item in, okay, if it was a numpy array, then so it would have been straight away. And now what would have we done if it was a numpy array? Hmm? Yeah, very nice. But in case of pandas, let's say you are just using a top 100 values, okay, and if you see the item now, if you simply use it like this, okay, for item in df.head, so you see what it became, just the column names. Okay, so you cannot simply do, even if this was not head, even if we take the whole data frame also, then also what would happen, only the column names would come simply. So that's why you need to use a special way. Okay, what is the special way for iterating? So df dot iter rows. Okay, this function returns a way, or you can say a generator kind of object. Okay, so basically it will, every time it would return one row and the index value. Okay, if you see, it will return what? An index value and the row. So if we print, let's say we print index comma row, and let's just do a df dot head so that we don't see 17,000 records. Let's just see 100 records. So every time this is, let's just go to start with, let's just go to two records for simplicity. So you see, this is the index, or let me put this on separate lines also. Now you see 0, and then this is the row. And for row, you see all both the things are coming, the column name as well as the value. Okay, now if I just want to get the longitude for every scenario or every row, I can do it like this. I select just the longitude from the row. How? Let's see the data type. Okay, let's see the data type of index, and let's see the data type of row. Okay, so index data type is an integer, whatever is the index data type, and the data type of this row that is coming, this is a pandas series. Okay, meaning a single, row is coming, or you can say a single kind of column where you have all the index values, column indexes, and the values corresponding to that. Okay, so let's say if this was your data, call 1, call 2, call 3, and 1, 2, 3, 4, 5, 6. Okay, if let's say this was your data, so every time in row what is coming, this much data first time. Second time, what would come? This and the column indexes, the indexes and the values, the indexes and the values, row by row. If this would have been 10, so 10 times we will get this. Fine, you see, 10 times you are getting longitude, or you can select latitude. Okay, this is how we iterate over a pandas data frame. Similarly, you have got items. There's also one way. Let's this one. So this basically inside row we have both the things. Now, like we have the entire, panda series. You see all these values. So basically, row means this entire data means a single row. Then this entire data means a single row. Then this entire data means a single row. Or up, this comes as a panda series. Okay, this entire value comes as a panda series. And this is the index of the series, the column indexes. Okay, makes sense? Fine. Any doubt in this? Oh, so let's try this once. Just give me a second. I'll also draw and show you. This would be easier to explain then. Okay, let's try this. Fine. Let's do this a bit down. Okay. This is getting removed. Fine. Okay. So let's say this is your data frame. Okay. This is column 1, C1, C2, C3, and C4. Fine. And these are different rows. Okay. And this is index 0, this is index 1, this is index 2. Fine. Now, now this is what a where it is wrong. This entire thing is what a pandas data frame. Makes sense? This is a pandas data frame, and each column is what? Very good. Pandas series. Each column is pandas series, so it is having heterogeneous kind of data type. Okay. Now, when we are iterating over rows, so what it's doing is, let let this get removed. So what it's doing is, when we are iterating over the rows, so each row that it is iterating over, okay, this row, let's say this is the row, this gets converted into a pandas series. Okay, and all these C1, C2, C3, these are the column indexes. These get converted as row indexes here, C1, C2, C3, so that row C1 would give you this value. Similarly, row C2 would give you this value. Okay, makes sense? So this is how it is converting the every row into a pandas series and returning back this iter rows function. Okay, fine. So we have now understood this also. Let's remove this. Okay. Now for item in df dot items, print item. Okay, let's see. Let's do a head of 10. Okay, let's just take 10. So now you see. Now this has. Let me also take it a little bit less. Let's just take 2 for now. Okay, now you see the this thing has changed. Okay, now what is happening is, if I choose, let's say, item and longitude, then what would happen is, most people. Acha, every time it is giving one only. No? Okay, okay, okay. Let's say if item, what we can take. Let me show you first what it's returning. So you see, first time it becomes okay. Let me just give some space also so that you understand what how it is changing. Hmm. See, first time it becomes longitude. Okay, this item. Okay, am I audible? Okay. And first time it becomes longitude, you see, so you get 100 and 100. Second time it becomes latitude, you get 100 and 100. So every column is being returned, okay, one by one using this items function. Okay, every column is being returned one by one. So I'll draw this again and tell you, that would be easier. So let's say if this was your pandas data frame, okay, iter rows was doing what, it was taking this and returning one by one in each row. But items is doing what? It is taking each column one by one and returning as a pandas series. Okay, so first time this column, second time this column, third time this column, fourth time this column. So every time you are getting one entire column. So let's say you want to do some operation row wise. So you will use what? Iter rows. Okay. If you want to do some operation column wise, so you do what? You return items. So what kind of operations you would do row wise? Let's say you want to check something that some value is greater than this in every row. Okay. So you will do a iter rows. If you want to check what is, let's say, the mean value or how many null values are there in every column, so then you will return column wise. We'll see also some examples, but for now you can just understand that how these are returning different things. Okay, make sense? Fine. Now we also have this df dot keys. Okay, let's see what this is returning. For key in df dot keys, print key. Okay, so this will just return the column names. Okay, if you just want to know what are the column names one by one, so you can use this df dot keys also. Fine. Now one is df dot iter tuples. For p in this, let's print p, and let's just do a head of 10 for now. Okay. Now what you will see, now see, now let's also do one thing, pandas type p. Now you see, this is again a, the type has changed. That was panda series, this is now a panda score frame. Okay, makes sense. So just understand this for now, that the type of this has changed, earlier that type was different, now the type is different. This you can understand. These are the tuples actually, if you see. Yeah, it is returning single row only. That is that. But if you see, let's say, you can also do like this, longitude. Just a second, I think this would be 0. Hmm. Let's take this as 1. Hmm. You see, this is changing. Using the indexes, we are able to change this. It's just that, whenever we are using iter tuples, this is a bit faster as compared to iter rows. No, that is returning Pandas series. This is returning a Pandas frame. Yeah, this is returning a Pandas frame. So that is the difference. Yeah, yeah, both are returning single row only. That is the same thing. But it's just that there is uh, one thing that iter tuples is faster than iter rows, because it's not creating a series object. It is just creating a named tuple. Okay. Uh, Let me show you one thing. Hmm, 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 hmm. Let me show you this. Oh, let me show you this. Uh, Let me do, yes, yes. Let me do this. Let's say we want to iterate over the entire thing. Okay, we are just printing. Okay, let's not print everything for now. Let's just do. Let's say we are doing some calculation. T of one, that is the longitude, into T of 2, that is the latitude. You know? You can also do like this to make this easier. Let me show you one more thing. T of longitude. This would be in. This is a named tuple only. One second. So we can use. Just this. I think this would require. Get PTTR. Let's use that function. Get. Fine, get ATTR, and from row we need to get longitude. Fine. So this is, let's take this and let's take latitude. Fine. Okay. And if this, instead of this, if we do iter rows, so I'm just showing you, when we just, let's say, simply okay, t, okay, let's reverse this. This is just t, and let's remove this. This is again t, and let's remove this. Fine. Now how many records we have in our data? Huh? No, we have around, if you see, no, no, no. If you see the length of df, currently we have 17,000 records. Okay. And what we are doing is, for every record we are multiplying the latitude and longitude value. Okay. Fine. Hello. That's right. This into this into this into this. For every row, we are doing this. Okay, just to show you what's the difference between iter tuples and iter rows. Okay, df dot okay, okay, okay. That's why it's so this is idx, and let's also do idx t t. This expected. Mhm. P, so that's P. Now you see, when we used iter tuples, then you see how much time it took, around 8.82 microseconds. And when we used iter rows, you see how much time it took, around 9.3 microseconds. This makes sense. So although the difference is very less because we have only 17,000 records. Okay, if we would be having very large number of records, then this difference would be more evident, because when we are working with named tuples, so these are a Python data types. Okay, then it is, we cannot edit, we cannot edit. That's right, and that's why it is fast. So you cannot do something like, you know t and uh, let's say t longitude is equal to 100. You cannot do something like this. That's right. In iter rows, you can do like this: p longitude, let's say if you choose, is equal to 100. See, it allowed this. But in if we just do this here, see, this is not allowing. Fine, and that's why it is faster. This wall time. Whenever you want to get, so these are known as magic commands in Jupyter. Using this percentage sign, you can do some magic commands. Okay, just by doing this percentage, and all you see, all these are magic commands. So basically, they allow some, like you can put in HTML in. Let's say if I do this, you are aware about HTML now. So let's say if I do h1 hello h1, let's do an h2 to, so you see, this like this you can perform many different types of magic commands also in. Yeah, because this is iter rows returns the index as well as the row. Okay, but in case of uh, this iter tuples, it just returns the pandas, named tuple kind of object. Fine. Oh, very good. Now we are done with iter tuples, iter rows. Now we can see one more functionality. There is this functionality where you can use, uh, let's say if you want to check. whether some value is in some column or not. Okay, or if some value is there. So let's say you can do like this. Let's say df dot is in. Okay, and let's say we give some values. Let's say 100. Let's just take top 100 columns, or let's just take top 10 rows. So you see for everywhere, because we had replaced this longitude to 100, so this would return true. You see, it is returning true for all the places where the value is 100. Otherwise, it's returning false. So this would check this value in the entire data frame. You can also do this. Let's say you want to check another value in the data frame. So you can also, so you see this became true. The latitude was equal to this. So using this, you can simply check also using isIn function. Fine. It is checking. So you can provide any number of values. So likewise, it will check for like this. And there is one more way if you want to check is in uh, if you provide it in form of a dictionary. Okay, let's say you provide the name of the longitude. That's right. And let's close the dictionary. So it would just check in this. You see here, this didn't became true. So it is just checking in this column. Okay, makes sense. Okay, very nice. This is also done. Isin is also done. Now let us take some data frame and let's start doing some initial analysis. Okay, let me download and upload some data frame for you, and we will use that data using pandas. We will start understanding how we can use that data. Let me just get it downloaded. Fine. Here I have downloaded. Let's put it inside sample data only. Okay. So this train.csv has been uploaded. Okay. Let me include, this is Titanic data. Let me import df is equal to pd dot read csv, and we will do train dot csv, df dot head. And now I'm actually showing you whenever you get any data, so what all type of things you will start doing. Okay, so this is known as EDA, exploratory data analysis. So you try, whenever you will get any data set, you will try to do some exploratory analysis, that like this df.info. You will see how many values are there. Okay, there are 891 values. So this data is of all the passengers who were present on the Titanic ship. Okay, so this is the data of that, and this 0 or 1 denotes whether that passenger survived or not. So this is a very famous data set used in start machine learning. Okay, so you have 891 passengers, and these are the columns: the passenger ID, whether survived or not, what was the class of that passenger. By class I mean like uh, first class ticket was there, second class or third class. Then what was the name, what was the sex, what was the age of the passenger. SP is number of siblings, if there were other siblings of this passengers on board. Okay, This parch is number of parents or children related to this passenger. This is the ticket number. This was the fare, the cabin ID, and the embarked from. There were multiple stations from where passengers embarked. S means something, C means something. Okay. There's also Q. I think three values are there. Now we can see df.info. There are 891 columns, and you can also see in for age we don't have all the data. So there are 714 non-null, and for cabin we also have less data, and for embarked we just have two less. Okay, two are null. Df, we can also do like this: df dot is na. Okay, now you see this is na function tells whether this value is null or not. है ना? Like we were using that is in function. Similarly, this is in is na, and you can also do like this dot sum. What this would do is for every column, this would calculate how many so null values are there. So is na would be true whenever the value would be null. This would be false whenever the value would be non-null. So true means one, false means zero in any programming language, and in especially in Python. If you do int of true, you will always get one. If you do int of false, you will get zero. And what would be this? Boolean of one. Boolean of one is, and Boolean of two is what? And Boolean of zero is false. So basically, anything that is non-zero is always true. Only zero is false. So do remember this. In any programming language, this is holds. So now we can see 177 ages are null, 687 values for cabin are null, 2 for embarked are null. Fine. Make sense? Okay. Now we can see uh, more what all data sets that we are having, and like what all columns are there, what all things we can do with the column. So let's say we want to check whether passengers survived or not survived. Okay. So let's see how many passengers survived and how many didn't survive. Okay. So how you can do that? What would you suggest? How using what? DF survived, and then we saw this function value counts last time. Using this, we can simply tell 549 people didn't survive and 342 survived. Make sense? Using this function, so 0 means didn't survive, 1 means survived. Okay. Now similarly, how many are there? Male, how many female? Let's see that. Let's say df of sex dot value counts. 577 male passengers, 314 female passengers. Okay. Now, how many male passengers survived and how many female passengers survived? Now we are actually starting with data analytics. How many male passengers survived and how many female survived? So how we can do that? So first, let's say we take df, and we can filter this df. This would be how many survived. And now what we will do? This would to give you this data frame of all the people who survived. Now, now you need to choose And df of what? Sex is equal to, and df of sex is equal to male. This so won't work. Why? Because one thing to, and we use this one. Or no, we can use this one also. But you will have to provide, whenever you are providing multiple conditions, na, you have to provide brackets. Ah, this one, and would work like this inside whenever filtering your data frame. Python mein you can use, but inside whenever you are using in a data frame, then usually you do like this. Fine. So these are 109 male who survived. And what about female? Sorry. So we want for female also. Now our question is this: how many male versus female survived? This is the question. So what you can do is, one second, I'll suggest something. Let's try that. So you using this, you will get all the data of survived passengers. From here, you take out the sex column, okay, and there you do the value counts. So basically, for all the survived passengers, you find the sex, and over that sex, you do the value counts. Make sense? So 109 males survived and 233 females survived. So this, data analytic person would say that there are more chances of females surviving the crash for Titanic. Okay, so this is, let's say we did one question. Now similarly we can see how many people of different classes, passenger classes survived. So how will we do that? DF, DF of survived is equal to, uh, very good. Let's see, P class was written like this only. Yeah, like this only. So now we can see that passenger class 1 was survived the most, passenger class 2 survived least, and passenger class 3 also survived. Fine. This is how we can form simple data analytic techniques. Okay. Now there is another way that you have also studied SQL. Okay. So in SQL you used to do group by. Very good. So let's say if we see group by here also, let's say I want to answer the same question. If I group by survived, okay. So what I'm doing, I'm grouping by survived, and I want to do a, let me get you sex and let me get you count. This should be count only. Yeah. No, I want to group by survived, and now you see. And let me just get a single column. Let's say, okay, let's see this first. Now what it did, I grouped by multiple columns, survived and sex. Okay. So for for one means people who survived. So out of that female were how many? total is whatever. 223 females survived, 109 male survived. You see, same we saw here. 468 male didn't survive, 81 female didn't survive, because we grouped by survived and sex. So this result, instead of doing this, we can also get like this. This count is different. As of now, this is same, but we are doing it over a group by. Value count is done over a pandas series, and this count is done over a group by. Okay, this is separate. Here you can also do mean. If you see this, what would happen? This would give you mean, but here, we are not having any particular column. So let's say if I do age, and if I find the mean. So now what this would tell me, for the, let's take one survived male, the mean age was this much. For the survived female, the mean age was this much. Survived female, who didn't survive, age was this much. If you see like this, if I don't do this, then what would happen? To get a series group by object. Okay, if I would have just done count, this would have just returned me count of this and this. But I did a mean, it would give me mean value. And if I would have done take, let's say, average sum, so it would have also done a sum of this, sum of ages. Okay, so everything is possible that you can try. But you see here, now what happens? Now earlier we were getting this result now, because this was happening on survived and sex. Now age is there, so it is calculating things based on age value. Okay, so 64 different ages are there of female who survived, 360 different male. So this is although a bit confusing, so let's avoid this for now. Let's just take this. Fine. Here we are grouping by this, and let's just take the sex. Okay, now you see 233,109. 233,109. Understood group by? This is like you do a group by in SQL. So similarly, you group by multiple columns, and for whatever column you want to calculate the value, you use a count, you use an average, you aggregate basically on that column. Make sense? Fine. And now let's see what else we can deduce. Male is done. Age also you are able to understand, mean age of different people. That also you are able to do now. Fine. Okay, let's see what we have. P class also we have seen. Mean sex. Fair. So fair depends on P class only, so nothing much. Age we have calculated. Embarked we can see. Okay. So people who survived, they embarked from which location? Let's see this. है ना? So for one who survived, maximum embarked from S. For who didn't survive, they also embarked from S. So nothing much interesting. For C also it's same. So using this, what happens is, why data analytics is so important. I'll tell you that machine learning as such is fine, but in real world data sets, when you are trying to do machine learning, okay, then your machine learning is only as good as what you are able to understand from the data. Okay, if you are not able to derive such kind of stats from the data, or such kind of relations from the data using data analytics, then machine learning would also fail. There is no magic, if there is no relation between survived and sex, or between survived and embarked, like we see here, then there is no way machine learning model would learn anything else. It will also learn from this data. In machine learning, what we are doing, so in machine learning we are training a model that, based on these values, these p class, sex, age, this siblings, parents, based on these values it can predict whether a person would survive or not. So this is what machine learning would do. But first we try to ourselves understand whether this data is fit for being served to a machine learning model. Okay, so let me show you also. Understand the data, understand the relationship. So traditionally what we used to do is, we used to have a software. Okay, so software would be given some input, है ना? And it would give what, some output, and there were multiple rules written. Okay, let's say uh, uh, if else conditions, है ना? Or some case conditions. Based on that, or whatever is the algorithm or the logic, okay, based on that the input would be converted to output. Now machine learning does what? Actually, machine learning is given the input, machine learning is given the output. Okay, and the objective of machine learning is to give you rules, these if else conditions, or these algorithms. Okay, based on the input, relation between input and output, you can get rules. So let's say you are taking precipitation and humidity. Okay, so at this precipitation and this humidity today it will rain, or at this humidity it will not rain. Okay, earlier you used to hard code this into a software. Now you are giving last 1 month data to a machine learning model, who is understanding that at what humidity it rains, at what humidity it doesn't rains. So this is what a machine learning model is trying to understand from the input and output relation, and spit out rules. Make sense? So this is nothing, nothing magical that it would do. It would just try to identify these relations. You see, using this thing, what are you able to understand? Just using this, seeing this data, seeing this data. Who has more chance of surviving? Yeah, who is having more chance according to this data? How? No, zero is, female is survived the most. So there are higher chances of female surviving rather than male. Okay, and this is what the machine learning model would learn based on this data only. Okay, so that's why it's very important to have a good holding on data analytics and understanding the data and all those things. Fine. Okay, very good. Now we have understood the basics of group by also. Now we'll also see the, there's another way to do some simple aggregations that we can do. So I'll show you aggregation. What we can do, df.agg. Okay, let's calculate the mean of MRNS mean. Okay, so for every column, it provided you what, the mean value, aggregate. Okay, you are trying to just do an aggregation. You can calculate mean, average, max. So let's say if you provide max, so what is the maximum value for every column? So for string columns, you see earlier when we calculated mean, name column was not there because name is not a float column. For a string column, you cannot calculate mean value. है ना? So that's why it was not there. But when we do a max, so you can see maximum length of the characters is chosen. Okay, fine, very good. Now let's say you want to add one more column, okay, where you want to check the length of the name. This is not useful for data analytics or machine learning, but it's just that I want to show you, or we can try that uh, how is this useful, or we can try one more thing. Mr. Miss, Mrs. We can, you see these salutations, Mr., Mrs., Miss, again Mrs., Mr. Okay, so how if we just extract this salutation of the name? Okay, let's see how many Mr. survived, how many Mrs. survived, how many Miss survived. Okay, let's see that from the name column. Okay, very good. For that, we would, uh, use some text extraction, and for that, the name column we are using. Okay, let's first take out the name column. Df name. Okay, fine. Now let's take the zeroth name, for example. So this is the name. What we can do is we can. This is what is the type of this? What would be the type? String. Very good. Now this is the name, and if we do a split, okay, on string, are you aware of split function? Very good. So we can split on this comma, है ना? And if we take the last element minus one, means this element would be written. This is zero. This is one. This is minus one. This is minus two. So this element would be written. Now if we do a split on, let's say, dot, then we get the zeroth element. Makes sense? We got what? Mr. And let's also do a, let's see if we have trim or what was that? Yeah, trim was not there, I think. I forgot the name of that. Where we can, fill the spaces in pandas. So strip, I think. Hmm. See, earlier there was one space. See, this space was there. No? So using strip, you can remove this space also. Let's check for any other value. Okay, very good. Yeah, you see, this is, let's say, this is your string. Okay, SD, and this is your string, and you just do a split. So this would return ASD. So we are getting this also fine. Very good. Let's check for 100. Very good. Now we want to run this on the entire data. Okay. meaning for every row. So now there are two, three ways to do this. Let's start with an easy way. Okay. First, let's make a list, an empty list. Okay. And let's go into for idx comma row in df dot iter rows. This we had seen, iter rows. And what we need to get from row, the name. So for from row we get the name, and on name we do this operation. Fine. And we save that into our list. We append that into a list. Now you see what is there in list. If you see all the salutations are there. Fine. Now what we do is we add this list as a new column, salutation, to our original data frame. See, now if you do a df.head, you will see a new column. See, just by doing df new column name and the list. And it's important that the elements in the list should be equal to the elements in your original data frame. So 17,000 should be there. Okay. So this is how. Now what we'll do is, let's say we do df dot group by and survived and salutation and extract this, and we do value count or just count. Okay. Series group by object is 1 second. Let me check this. What were we doing earlier? We were doing this only, no? Counts. Oh, sorry. We are using. Yeah, we just use count. Now you see on salutation. So basically, what you can do is see maximum category who died was miss. You know, no, who survived was miss, and maximum category who died was Mister. And after Mister, it was Miss. Here, Mister was very less who survived. So Miss was the most who survived. Misses were still less. Okay. Then what else you can see? There were 3 doctors who survived, 4 doctors who died. Master, if you see, 17 died, 23 were survived. Okay. So mainly miss, you can say that if it is miss, then there are more chances of surviving. If misses, then again more chances of surviving. If mister, then very less chances of surviving. If REV, then there are no chances of surviving. You see, there are 6 here, there is no one here. So there are no chances. If anyone is having this REV surname, then you see this REV means what? If we check this REV surname salutation reverend. Okay, make sense? So this is how we do analytics. Okay. Okay. Sorry, bye. Uh-huh. That's right. That's right. That's right. We'll play around with lot many data sets. So this is to just the start, very basic data that we are using. And you see, we have done a lot many things today, very interesting things, and we can now ourselves, predict or tell that what which group is having more chances of surviving versus which is not having. Okay. Now I'll also share you the link for this data set, or I'll share the data set also. So you can now try these things at your end also. Tomorrow what time? Let me 1 second. Let me pause this.